In this video, we'll use factorial and double factorial to generate the Taylor-Maclaurin series sum of the hyperbolic sign. We begin with the dataset of the hyperbolic sign. Array formula, hyperbolic sign of the x values from -2 to +2. And we'll chart this. Insert chart, and we use scatter chart. Row 1 as header, and show the trend line. Polynomial, use the equation. Our polynomial degree is 8, and for the legend, position at the bottom. Here's our trend line and polynomial of the hyperbolic sign. Continue with the expansion, which is the summation of a times x to the power 2n plus 1. And the value of n start from 0 up to infinity. 16 is good enough. Now we calculate the factorial coefficient. So array formula, 1 over factorial 2 times n plus 1. And the double factorial, which is array formula, 1 over, now there are two parts, double factorial, 2 times n. The second part, double factorial again, 2n plus 1, 2 times n that's 2 times n, 2n plus 1. Their values are exactly the same. So these are exactly the same. Now we can calculate the series sum expansion. Array formula, series sum of the x values raised to the power 2n plus 1. So 2n plus 1 starts from, at n equals 0, 0, so 0 plus 1, 1. So it starts from 1. Followed by 2 times 1 plus 1, 3. Then 1, 3, 5, 7, 9. So the interval is 2. And the coefficient, we can use double factorial or factorial. We can start with the double factorial. We don't have the polynomial. We do have the points. They are on the same points on the line. Let's edit the chart to show the trend line. Trend line, the type polynomial, the degree, same degree, 8. For the label, use the equation. So the equations are exactly the same. Now we continue with we'll calculate the polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. So transpose 0 to 8. Now the elements of the matrix. So array formula of the x values raised to the power 0 to 8. Then enter. Now we can use LINEST. LINEST data y and data x. LINEST data y and data x. Let's compare the coefficient against our chart. So the coefficient of x to the 0, 0. Coefficient of x, 1. Coefficient of x squared, 0. Coefficient of x cubed, 0.167. Coefficient of x to the 4th, 0. Coefficient of x to the 5th, 8.28 times 10 to the minus 3. Coefficient of x to the 6th, 0. Coefficient of x to the 7th, 2.2 times 10 to the minus 4. And coefficient of x to the 8th, 0. That's because we use the double factorial. Suppose we use the factorial. So we're using the factorial coefficients. We still get the same polynomial regression coefficients. The polynomials remain the same. The trend lines are still the same. And the datasets, they're still the same. This completes the use of double factorial and factorial to generate the Taylor-Maclaurin series sum of expansion of the hyperbolic sine function and its LINEST polynomial regression.